proceed with the other example that we have here in solving for our arithmetic mean. So for example, we have to solve for the 4 arithmetic mean of the sequence 5. So we need to solve for the 4 arithmetic mean of our arithmetic sequence. Okay, since the common difference is not given, so we need to solve for our common difference by means of using our formula for arithmetic sequence, which is an equals to first term plus n minus 1 times d. Okay. The value of our an is the last term in our sequence, which is 15. So 15 equals to 5, since 5 is our first term, plus the value of n. We have a total number of terms in a sequence, which is 6 minus 1 times d. So 15 equals to 5 plus 6 minus 1 is 5. 5 times d is equal to 5d. Combine similar terms, we have 15 minus 5 equals to 5d. So 10 is equal to 5. Divide both sides by 5. So our common difference is equal to 2. So since we have already our common difference, we can now proceed in finding the arithmetic mean between 5 and 15 by adding the common difference that we have solved, which is 2. So 5 plus 2 equals to 7. 7 plus 2, which is equal to 9. 9 plus 2 is equal to 11. And 11 plus 2 is equal to 13. So the arithmetic mean in our sequence is 7, 9, 11, and 13. So that is our arithmetic mean. Okay, questions for arithmetic mean before we proceed with arithmetic series? Okay na tayo with this one. Okay, so let's proceed with arithmetic series. Okay. So when we say arithmetic series, that is an indicated sum of terms in an arithmetic sequence. So when we are solving for arithmetic series, we are just finding the sum of the sequence that we have. So when we say sum, that means addition. You're just adding all the terms that is present in the sequence. But we have the formula that we can use to find the sum of our arithmetic sequence kapag madaming terms. Okay, for example, you have 100 terms. To make it easier to find its sum, we have the formula that we can use in finding the sum of our arithmetic sequence. For example, that is our arithmetic sequence. Our arithmetic series is just adding each term, which is 3 plus 5 plus 7 plus 9 plus 11 plus 13. So it's more on adding. Okay, for arithmetic series, it's just addition. You're just finding the sum of each term that you have in the sequence. Okay. So for example, we have to find the sum of the first 63 terms of our arithmetic sequence. Given that we have the arithmetic sequence negative 19, negative 13, negative 17, we need to solve for the sum of our arithmetic sequence. We have the formula that we can use in finding the 63 terms of our arithmetic sequence, which is sum of arithmetic sequence equals to n divided by n multiplied to the sum of the first term and the last term. Okay, that's the formula that we're going to use, wherein n stands for the number of terms, a sub 1 stands for the first term, and an stands for the nth term. And Sn stands for the sum of terms. So this is the formula that we are going to use to solve the sum of the specific terms in our arithmetic sequence. For example, we have to solve for the sum of the 63 terms of our sequence, negative 19, negative 13, and negative 7. Given in the formula that we have for the sum of the sequence, which is Sn equals to n divided by 2 multiplied to the sum of the first term plus the nth term. Okay. So we need to have the value for n. Okay. The value of n in the problem that we have is 63. Since that is the number of terms that we are going to solve. So n is equal to 63. Our first term is equal to negative 19, which is here in our sequence. But we don't have the value for our nth term. We need to solve for the nth term before we have the sum of our arithmetic series. So, since we are missing the value for the nth term, we're going to use, let's go back to the formula of our arithmetic sequence for us to solve for the nth term, which is an equals to the first term plus n minus 1 times d. Since we're solving for an, we have the value of the first term, which is 19, and we have the value of n, which is 63, minus 1, and our common difference based in our sequence is positive 6, since negative 19 minus negative 13 is equal to positive 6. So that is our common difference.